students, so this is from the review that was due Monday. And the first question here was from the three representations. So you had this one that was an equation in standard form. So this is equation in standard. Representation 2 was a table, and representation 3 was the graph. They're asking me which one has the greatest slope. Okay, so when I'm talking about greater slope, excuse the announcement.
Isaac Gasta to the college step office, they're here to pick you up. Isaac Gasta to the college step office, they're here to pick you up.
So this one's for a steeper line when we're talking about greater slope. So over here, if it's in standard form, it doesn't really help me out. So I need to have it in slope intercept form, which is y equals mx plus b. If I have it in this format, I know that the slope would be the m, so it's easy to distinguish. So that means I'm going to have to solve for y here so that I can tell what the slope is. In order to do that, we have two steps. Step 1, move the x over with inverse operations. So there's no sign over here, then that's a positive, so the inverse would be a negative 2x. That zeroes out. I still have negative 5y equals. I'm going to put the x first because I wanted to be first over here, so it doesn't matter the order. And then the 20 is positive. Now I have one final step to get the y by itself, so I need to divide by negative 5. And I have finally isolated the y. So negative divided by negative would be a positive, so I would have positive 2/5 x, and then this is minus 4. So from here now I know that my slope in representation 1 was the 2/5. Okay, I'm going to move over to representation 2. So here I have a table of values. So in order for me to get the slope, I can do change in y over change in x. And I don't need the whole equation, I'm only talking slope here. So the change in y would be plus 3, and the change in x will be plus 1. 1 plus 3 is 4, negative 3 plus 1 is negative 2. So change in y over change in x would be 3 over 1, which is 3. So this one would be the slope in my second representation. The third one is a graph. So on the graph, I will do rise over run. So I'm going to start here at the intercept, and then I'm going to find another point that is right on the grid so that I can count my rise over run. In this case, it would be like, for example, that point here. So I'm going to start from the top, and from the top I'm going to go up 1, 2, 3, 4, and then I run 2, and it's to the right. So they're both positives. Okay, so then I have my rise over run, which is my slope, positive 4, positive 2, so that's 2. So this is the slope of the third representation. So then when I compare all of them, the steeper slope would be the greater slope. So the higher the absolute value of the number, whether it be positive or negative, the steeper the slope is. Okay? So for example, this one is the larger number. This would have a steeper slope than this one. And then finally, that one would have the less steep. So in the answer, I would say representation 2 has a steeper slope. Okay, so that's number 1. I'm going to turn the page over. I'm going to skip to number 3. Excuse me. Okay, number 3 is a little bit difficult because it has more steps. So here they're telling me that this line, write the equation of the line, so a line here, that is perpendicular to this one. So this is a new line that I am going to do that is perpendicular to this old line right here. So, and then they tell me only that information and also that it passes the point to 5. So if my old line is y equals 2/3 x minus 5, The only thing I can get out of here, because they're telling me it's perpendicular, I know that the slope will be opposite sine and reciprocal if I want a perpendicular line to this old one. So that means my new line would have not a slope of 2/3, but a slope of 3/2, and because this is positive, the new one will be negative. So my new M is this. So I'm going to put here new line. M (-3/2). And then I also have a point, so an x1, y1, which is 2 and 5. So if I have a slope and a point, I'm going to use slope-point formula, or point-slope formula. And all these formulas, remember, are on the back on your test on the formula chart. So you don't have to memorize any of these. From here, I'm going to substitute in those values. And we practice this several times. So then I'll have y minus, y1 is 5, equals m. And then x minus x1, which is 2. Okay? And then I'll just solve it. And here it doesn't tell me how to write the line, but I'm going to write it in slope-intercept form. So in y equals form. So I will distribute here. You can do the box on the side, or you can distribute like that. So (-3/2 x. (-3/2 times (-2). If you have trouble multiplying fractions, do it on the side. So I'll do it right here. (-3/2 times (-2). You can multiply across or cancel these 2's out and have the 3. If you multiply across, you'll have positive 6, because 3 times 2 is 6, and 2 times 1 is 2. Okay, so then that gives you 3. So I'll go over here and put my plus 3. Then my last step here will be to isolate the y, will be to get rid of the minus 5. So the inverse will be plus 5 to zero it out, and plus 5 on the other side. And then that will be my answer. This line will be perpendicular to this original line because the slopes are reciprocals of each other and opposite signs. And then I figured out what the y-intercept would be with the point that they gave me. Okay. Over here, I just want to do number 5 and number 6 in the back. Number 5 and number 6. Number 4 is really similar to the one that we did. In order for you to know if they're parallel, make line B y equals, and then compare the slopes. For number 5, they want a line that is parallel and perpendicular to y equals 7. So the first thing that I'm going to do is kind of graph it to get a visual. So this is my y and my x, y equals 7. So this is where like 7 could be. And I know that if it's y equals, anything that's y equals is going to be a function. So I know that it's missing the slope. So if it's missing the slope, that means that this will be a horizontal line because it's missing the slope. It doesn't have an x. Okay? So then that means that line is this. So this line is y equals 7. Now I need to draw a line that is parallel and one that is perpendicular to this. So parallel will be another line like that. So I can do, I don't know, this one right here. And let's call that, that looks like it could be maybe like -4. So y equals -4. And then one that is perpendicular. The only line that can be perpendicular to a horizontal line has to be a vertical line, because remember, perpendicular lines need to make a 90-degree angle. So this has to be a 90-degree angle, okay, when they cross and they intersect. So the only way to do that is to have a vertical line. So I'm just going to put it right here. Remember, vertical lines are the only ones that are not a function, and the only ones that are x equals whatever number it is, because at every point in that line, it's going to have the same x value. So this looks like it would be like x -4 or so. Okay, so perpendicular would be this one. and parallel will be this one. Okay, so that concludes this video for that first review. Okay, actually no, I'm gonna do this one as well, although we went over it in class. Okay, so first of all, in order for you to know if a sequence is arithmetic, okay, you need to know that there's a common difference. If there is no common difference, that is not arithmetic. So here I did this table for you to help you out. To help you out, think of it as a linear function because all arithmetic sequences are linear. Okay, the common difference is the slope in all of them. So over here, I'll fill this out by counting the rings. And then I'll check to see if that common difference is there. And yes, it is. Plus 1, plus 1. So it is an arithmetic sequence because there's a common difference of 1. Okay? Here they're asking me to write the recursive. Okay, if they're asking me to write the recursive, I need to have the first term. Okay, so first term goes first here. And this one, it would be 2. 2 is my first term. And then the other part of the recursive formula will be the last one and then plus common difference. Okay? And we know the common difference is 1. This, where it says last one, all you have to do is represent it at a n equals n minus 1. This means last. Okay, the previous term. And I know that my common difference is 1. And a of 1, which is the first one, would be 2. Okay, so just follow this format to do the recursive. Just remember that you need to have the first term in recursive. If the first term is not there, you can't do recursive because you need to start it with that first term. And then what this is telling us that any number you want, you need the previous one and add 1. For example, if I need a of 2, like the second after this one, I need the previous one, which is a of 1, and then plus the common difference. So that would be 2 plus 1, 3. And yes, the second term is 3. Okay? So just remember this. Common difference if it's arithmetic, and also that you need the first term if it's recursive. If you're going to use recursive formula for this sequence. Now with all of that, I told you during the lesson that we're going to use these formulas very little, but we will use linear functions a lot. That's why I gave you this table, to remind that arithmetic sequences are linear. Okay? That common difference is your slope. So over here, when they're asking me to do the linear function, we can do it old school like we did at the beginning where we had our 3-column table, or you can use your y minus y1 equals mx minus x1. You already know the slope will be your common difference in any arithmetic sequence. And then you can use any point, like for example, this point 1, 2, you can use it here. Oh, sorry, this is 2 and this is 1. Sorry about that. Okay, and then you can come up with the formula here. You can do it like we did at the beginning before we knew how to use this formula, where you know that you have, it's you need 2 points, like 1, 2, and 2, 3. And then this is plus 1, so you know your slope is 1. And then you multiply it by the y, by the x. 1 times 1 is 1, and how do I get to 2? Plus 1. 1 times 2 is 2, how do I get to 3? Plus 1. So both of these will give you the same formula, which is y equals 1x plus 1. Because this is a sequence, they usually don't use x, they usually use, and they don't use y, they usually use f of n, like I did in the example. 1n plus 1. So they use function notation with the n rather than the x. Okay, and then finally to calculate for the 11th number, and over here f of 11, that means the input is 11. Remember the heart. If this is my function, instead of n, now I want 11, I'm going to replace that with 11. So that would give me 12. Okay? So that was the last problem. Now, finally, this video comes to a conclusion. I will post another video for today's homework and an exemplar for the one that was due today as well.